radicals. You're supposed to realize that radicals are nothing else, just different way to write rational exponents. Rational exponents means exponents which are expressed in terms of fractions. Okay? Before I'm going to go to the laws, let me just remind you that we have radical. Radical contains radical sign, this is radical sign, radicand, which is going to be variable or number, or index, which is going to be number over here. Anytime you are not going to have any number over here, means there is always invisible 2. Okay, keep this in mind. Now, laws of radicals. As I said, radicals, this is another way to write rational exponents. The very first law says n root of a. Remember, anytime we do not have any exponent next to the variable, there is always invisible 1. Okay? And the definition says that this radical is equal to a to the exponent 1 over n. It means that exponent which is next to a goes to the numerator and index goes to the denominator. Let's take a look at another law. Again, remember the index will go always to the denominator of our exponent. Exponent of my radicand will go always to the numerator. That's why this radical is equal this form. Okay? Now, someone is going to say, why this is equal to this? Okay? I would like to just remind you that we can have situation like this. We have a 1 over n to the m power. If you are going to look at the very first law, n root of a is equal a to 1 over n. Okay? So that's why I convert this radical to this form. I have m outside of the parentheses. Remember, anytime we have exponent outside of the parentheses and exponent inside of the parentheses, we're supposed to multiply them together. So in this case, we're going to multiply m by 1. That's why this is going to be equal a m over n. Now, let's take a look at another law. Now, we can rewrite this radical as an exponential form, and I'm going to have a over b. And remember, anytime we do not have exponent, right, we have always invisible 1. That's why I'm going to have always invisible 1, which I'm going to make visible, and I'm going to say this is 1 over n. Remember, index of my radical goes always to the denominator. The exponent of my radicand will go always to the numerator of my exponent. So now I can say that this radical is equivalent to this form. I can say that anytime I do not have an exponent, there is always invisible 1. Remember, we said that anytime we have external exponent and internal exponents, we have to multiply external exponent by the internal exponent. So I'm going to have a 1 over n, and I have b 1 over n. That's why this radical is equal to fraction n root of a, n root of b. Remember, n root of a is nothing else just a 1 over n, and n root of b is equal b 1 over n exponent. Okay? So again, we apply the rules of exponents. Now let's take a look at this example. Again, what we are going to do, I'm going to add parentheses and invisible one, I'm going to make visible. Remember, we have always invisible exponent, which is always 1. Now, I can rewrite this radical as an exponent form. So I have a, b. Remember, exponent goes always to the numerator of my exponent, and the index will go always to the denominator. Remember, we spoke about the exponents, and we said anytime we have product raised to the power, we have to multiply every internal exponent by external exponent. That's why I'm going to say a 1 times 1 over n is just 1 over n, and I have b 1 times 1 over n is just 1 over n. As you can see, radicals are nothing else just exponent, but rational exponent. Exponents which are expressed in fractions. Now let's take a look at the definition of the square root. Remember, I said that anytime we do not have any number, right? Anytime we have no index written next to the radical sign, okay, there is always invisible 2. So we can rewrite this radical square root of a is equal a to 1/2. Remember, exponent of my radicand goes always to the numerator, invisible 2 goes to the denominator. The definition says square root of a is equal b, right? So let me just write this down and say a 1/2 is equal b. Now, I want to find a. In order to find a, I have to eliminate this fraction, okay, this exponent. In order to eliminate that, I have to again apply the rules of exponents. Okay, if I want to eliminate this fraction, I have to multiply that fraction by 2 by adding exponent 2 to the whole expression. Whatever I did on the left side, I have to do also on the right side. 2 and 2 will cancel out. That's why I have a equals b squared. This is my definition. Remember, b has to be always greater or equal than 0. Now, let's do some problems.